Section 22 of the Science, History of the Universe, Volume 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Science, History of the Universe, Volume 1. Edited by Francis Rolt Wheeler. Astronomy. Chapter 15. Mars, Part 1. Mars is another instance of a celestial body whose discovery long antedates written history, for which reason it is natural to assume that its appearance in the heavens and its motions have always been known to mankind. Its ruddy light naturally associated it in the Greek mind with the god of war, just as the soft, warm glow of Venus was considered appropriate to the goddess of love. To the Chaldean and other ancient stargazers, the motions of the planet were indeed of interest. No planet has received greater attention from astronomers, or has been used more for the solution of important astronomical and cosmical problems. Thus, it was from the observation of the passage of the moon in front of Mars, or what is termed by astronomers an occultation of the planet, that Aristotle concluded that the planets were more distant than the sun and moon. What reason he had for including the sun is difficult to conceive, as an occultation of that body would be quite impossible. Later, it was from the study of the motions of the planet made for Tycho Brahe that Kepler was able to derive his great laws of planetary motion. By observing the great hourglass sea, or Syrtis Major, on Mars, Huygens, in 1659, noted the rotation of the planet on its axis, and from a measurement of the planet made its opposition Richter was able to obtain a reasonably accurate estimate of the distance of the sun in 1673. 1783, Herschel had written, "The analogy between Mars and the Earth is perhaps by far the greatest in the whole solar system." For over a century, the development of this analogy has been one of the most important features of astronomy, especially in popular estimation. Today, with a wealth of scientific and observational data acquired during the last score of years, the question, although more fully and intelligently discussed, is as far from solution as ever. Mars revolves around the Sun in an orbit whose mean distance is 141,500,000 miles. But this orbit is so eccentric, amounting to 0.093, that the distance varies about 13 million miles. As this distance from the Sun is about one-half as far again as that of the Earth, the light and heat that Mars receives are only about 4/9 of the light and heat received by the Earth, an important consideration in discussing the possibility of life on its surface. The real diameter of Mars is about 4,200 miles, a figure correct within 20 miles, so that its surface is 23/100ths and its volume is 0.147 or 1/7 that of Earth. The mass of the planet, derived from observation of its satellites, is about 1/9.4 that of the Earth, so that its density is 0.73 and the attraction of gravity on its surface is 0.38 that of Earth. Mars reflects 0.26 of the light that it receives, which is just double that of Mercury. In Mars may be seen a striking difference between the superior and inferior planets, for the crescent phases of the latter are conspicuously absent. This is because the orbits of Mars and the other superior planets lie outside that of Earth. Consequently, such a planet never comes between the Earth and the Sun. At quadrature, a certain amount of the unilluminated portion is turned towards the Earth, so that the planet appears like a moon 3 or 4 days from full, with a distinctly gibbous appearance. Kepler suspected the existence of satellites from a somewhat cryptic utterance of Galileo's in regard to the triple Saturn. No particularly sound reasons were advanced for the existence of such satellites. Still, that they might be found is forcibly reflected in 18th century literature. In Gulliver's Travels, 1726, is the striking statement that an astronomer on the floating island of Laputa had discovered 2 tiny satellites of Mars. Dean Swift even advanced the extraordinary statement that one of these moons revolved around the planet in 10 hours, the approximate correctness of which will presently be apparent. Furthermore, Voltaire, in his Micromegas, published in 1752, and obviously modeled on Gulliver's Travels, also speaks to these small bodies. Although literature and imagination had preceded observation, astronomers could not detect any companions to the ruddy planet until August 11, 1877, when Professor Asaph Hall, using the 26-inch refractor of the U.S. Naval Observatory at Washington, which at the time of its construction in 1873 was the largest telescope in the world, studied the vicinity of Mars with unusual care. In 1877 it was at conjunction, so that conditions were favorable for an exhaustive inquiry. On August the 11th, Professor Hall detected a minute speck of light near the planet, and a few days later, August 16th, he ascertained positively that it was a satellite. On the following evening, a second body was discovered, bewilderingly rapid in its motion. Since that time, the two satellites have frequently observed at opposition even with much smaller instruments. On July 18, 1888, the Large Lick telescope was able to reveal them with their brightness was about 1/8 at the time of their discovery. The names appropriately designated to the new satellites, Deimos and Phobos, Fear and Panic, were taken from the Iliad and represent the companions in the battle of the god of war. The satellites are very small, having diameters respectively of 6 and 7 miles, as photometrically measured at Harvard University soon after their discovery by Professor Pickering. Phobos, the inner, is larger and travels an elliptical orbit in 7 hours, 39 minutes, and 22 seconds at a distance of only 3,760 miles. Deimos, its companion, moves in a nearly circular orbit in 30 hours, 18 minutes, at a distance from the planet of 12,500 miles. It should be remembered in all discussions of the nature of the surface of the planet Mars, and in developing theories based therein, that astronomers must deal with the little disk which one every 15 years has a maximum of about 1/5000th the area of the full moon. When the nearest Earth Mars is at a distance of 35,500,000 miles, and when observed by a telescope magnifying 1,000 times, it appears as only as large as the moon with an ordinary field glass, enlarging 6 or 7 times. In other words, Mars is brought to its distance of 35,500 miles. Hence it is difficult to distinguish minute details. Consequently, visual and photographic observation of Mars must be of the most refined character, for especially in the former there is opportunity for psychological or subjective phenomena to occur in connection with the observation. While it is neither rational nor scientific to deny what credible observers claim they have seen through the telescope in examining the planet, yet it must be recognized that visual observations are attended by necessary limitations and should be received in a spirit of caution rather than of enthusiasm. The mapping of Mars is no recent matter, for even in 1659 a rough sketch of the surface of the planet was made by Huygens, in which the V-shaped marking at the equator pointing to the north can be identified as the Syrtis Major. This was followed by rough sketches from time to time down to 1840, when Maedler first began a systematic charting of the planet. His map was followed in 1864 by Kaiser's, by Flammarions in 1876, and Green's in 1877. Drawings of various parts of the planet were made during these intervals, but were not combined into good charts. Observations made by Professor Lowell and his staff at the observatory in Flagstaff, Arizona, have had the study of this planet especially in view. The Lowell Observatory itself is situated 7,300 feet above the sea and contains an excellent 24-inch telescope, with which it is claimed that the faintest stars shown on the chart made at the Lick Observatory with its 36 instrument are perfectly visible. The atmosphere is well adapted for telescopic work, so that Professor Lowell and his colleagues possess singular advantages over other observers. On the other hand, in many important respects, there has been a lack of corroboration of their observations. The surface of Mars, as seen in the telescope, is composed of 2 white polar caps which wane with the approach of summer, orange areas, which are supposed by Lowell and his followers to be deserts, and blue-green areas which change their hue to orange during the Martian autumn and winter and reassume their verdant tint in the spring. The planet is covered with a network of fine lines first discovered by Schiaparelli in 1877 and called by him canals, a designation by which they are still known. These canals connect the polar ice caps with the temperate and equatorial zones. According to Professor Lowell, they may be regarded as planetary irrigation ditches, which serve the purpose of leading the melting water of the poles to those desert regions which would still blossom if properly watered. The canals disappear with the approach of winter and creep down from the poles towards the equator in the summer, a phenomenon which long puzzled astronomers until Pickering ingeniously suggested that we see not the canals themselves, for they are much too narrow, but the vegetation which fringes their banks, which withers as the cold of winter descends, and which flourishes with the melting of the snows. It was Schiaparelli who also first announced the curious doubling of the canals in certain instances, an announcement which was at first received with derision, but which has since been confirmed by his disciple, Lowell, and the astronomers of the great observatories. This curious gemination has not been satisfactorily explained, although Professor Lowell attributes it part to vegetal causes. By opponents of his theory, the doubling is regarded as an optical illusion, which can hardly be the case, because all and not certain of the canals would exhibit the phenomenon. Furthermore, there is some photographic evidence offered by Mr. Lampland of Professor Lowell's staff that both the canals and their doubling are real. End of section 22.